Welcome to Do the Math America. I am Charlene, the Math Shaman. This is my 27th video that I've made on math lessons. And if you've been watching my videos all along, you know that I've been adhering to this textbook. We have now reached the point in your math learning where it will be very beneficial for you to obtain a hard copy of this textbook. Unfortunately, it is out of print. But there is a link to the PDF in the description box below this video. Please use that PDF file to obtain a hard copy. You can use your home printer, but if, like me, your home printer doesn't work, you can go to the public library or the UPS store or Office Max, or just do a search for businesses in your area that will print out material for you. It's worth having a hard copy because getting to the point where you might have to refer to earlier lessons to trigger your memory on how to do a skill. For example, we are adding and subtracting fractions today. You might need to go back to the section on adding and subtracting integers to get clear on how to do that properly. When you're doing practice problems, you will find that it's absolutely critical to have a hard copy of those problems because it's very easy to copy down a problem incorrectly. And there's nothing more frustrating finding out you have the wrong answer because you copied the problem wrong from the very beginning. This is what I do to make sure I copy the problem down correctly. It starts with a negative symbol, and then we have numerators and denominators and parentheses and more negative signs, close parentheses. So I write this problem down, and then I use my index fingers and I make sure that I copied each character down correctly. So I've got my negative sign, my numerator, denominator, negative, another negative sign, parentheses, open parentheses, a negative sign, the fraction, close parentheses. I do this tracking, making sure that I got all the symbols and characters written down perfectly. That way I know that at least I'm starting out with the right problems. This video is long. Can't make it any shorter because we are covering a lot of ground here. However, I have included timestamps for you in the description box below. Please use those, and you can pause the video at any point, take a rest, or take a look at the corresponding practice problems. It would make sense to watch this video in several sessions. You watch the beginning section on how to add and subtract fractions that have the same denominator, and then you go to the section in the exercises that have those problem sets. So for the first 35 problems in the exercises, those problems all have common denominators. So practice those, take a break at that point for the day. Go play some basketball or some pickleball with your friends, or just something to get the blood circulating. You need that blood going to your brain. And then come back to the videos and watch the next section on how to manage fractions with different denominators. That is a much bigger section. And then practice those problems. They might take you a couple of days to go through those problems, and then come back and watch the videos on how to solve word problems. And then again, then go to the practice problems and make sure you take on the challenge of solving word problems on your own. And then always check your answers with those in the back of the book so that you make sure that you did the problems correctly. Being able to add, subtract, multiply, and divide fractions is a very powerful skill. You can do things like figure out how many 2x4s do I need to buy in order to build a deck. I want to earn some extra money by selling cookies. How do I multiply my recipe by 7 times? There's a lot of fractions in recipes usually. And if you can handle that, then you can make your recipe properly. And even how much money do I sell my cookie for and cover my costs and make some money and not lose money? These skills you see are going to be very helpful for you in your life. Adding and subtracting fractions are covered on pages 65 through 68 of the Beginning Algebra book. Rules for adding or subtracting fractions. 1. If the fractions have a common denominator, we combine, add or subtract, the numerators and write this result with the same denominator. 3/5 plus 1/5 have the same denominator, so we simply add the numerators, 3 plus 1, to equal 4, and we end up with the fraction 4/5. 3/5 minus 1/5 also have the same denominator, so we subtract 3 minus 1 to get the numerator of 2, and we keep 5, the denominator, ending with 2/5, the fraction. And we remember to box our answers. 3/12 minus 7/12. These fractions have the same denominator, so you keep the denominator. And for the numerator, you treat those as if they are integers when you're adding and subtracting. Pages 13 and 15 of this textbook covers how to add and subtract integers if you need a review. Otherwise, you may watch my earlier videos, lessons 8 and lesson 9 on adding and subtracting integers. So 3 minus 7 equals negative 4, and we have 12 in the denominator, and so we prime factorize the numerator and get 2 times 2, and the denominator is 2 times 2 times 3. We cancel like terms from the numerator and denominator, so the 2's cancel, leaving negative 1/3. And box your answer. 2. If the fractions have different denominators, we rewrite the fractions with a common denominator before adding and subtracting. 1/2 plus 1/3 have different denominators, so we find a common denominator by multiplying both denominators together. So 2 times 3 equals 6, which will be our common denominator. We convert 1/2 into an equivalent fraction with 6 as the denominator by multiplying both numerator and denominator by 3. And then we convert 1/3 into an equivalent fraction with 6 as the denominator by multiplying both numerator and denominator by the number 2. So 1/2 becomes the equivalent fraction, 3/6, and 1/3 becomes the equivalent fraction, 2/6. And now we have two fractions with the same denominator, and so we keep 6 in the denominator and add the numerators, 3 plus 2, to equal 5. 5/6 will be our final fraction. 3/4 minus 11/12. So we can see that 4 is a factor of 12, and if we multiply 4 by 4 times 3, we will equal 12. So we need to convert 3/4 into an equivalent fraction with 12 as the denominator by multiplying both numerator and denominator by 3. When you are doing a problem like this that takes multiple steps, it is a good idea to write down the calculation you need to make and recopy the rest of the problem onto the next line so you keep track of the entire problem. 3/4 becomes the equivalent fraction 9/12, and now we have 9/12 minus 11/12, or 9 minus 11, which equals negative 2 over 12. And since those are both even numbers, we need to simplify the fraction by factoring out 2 from both numerator and denominator, leaving us negative 1/6 for our final fraction. And we box our answer at the end. Three, convert mixed numbers to improper fractions before adding and subtracting, or use vertical form to add or subtract mixed numbers. 2 2/3 plus 3 1/3 have the same denominator. We can start by converting these mixed numbers to improper fractions by multiplying the denominator by the whole number 3 times 2, and then we add the numerator 2 to get 8/3, and then for 3 1/3 that becomes 3 times 3, which equals 9, plus 1, which equals 10/3. The numerators 8 plus 10, and we keep the same denominator 3. That gives us 18 over 3, or 18/3, which is the same as 18 divided by 3, which equals 6. So the answer is 6. Another way to approach this problem is to add the whole numbers and then add the fractions together separately. So 2 plus 3 equals 5. And then we add 2/3 plus 1/3. So we add the numerators 2 plus 1, which equals 3, and we keep the same denominator 3, which gives us 3/3. So we have 5 plus 3/3, 5 plus 1, which equals 6. Next problem, 2 2/3 plus 4 5/6. So we can see that the denominators are different in this equation, so we can't just add the numbers together. I start by converting the mixed numbers into improper fractions by multiplying the denominator 3 with the 2, the whole number, and add the numerator 2 to get 8/3. And then 6 times 4, which is 24, plus 5, which is 29, over 6 for 4 5/6. Next, I need to put both fractions in a form in which they have a common denominator, and I see that 3 is a factor of 6. 3 times 2 equals 6. So if I multiply both 8 numerator by 2 and 3 the denominator by 2, I will get an improper fraction that has a denominator of 6. Before I do that, I complete the equation on the same line, and on the next line I write out the equivalent fraction of 16/6 plus 29/6. So we just add the numerators now, and we get 45 over 6. At this point, I will do a prime factorization of both the numerator and denominator. 45 factors out to be 3 times 3 times 5. And 6 factors out to be 2 times 3. Now I write out the factors corresponding to the numerator and denominator, and once I line up the factors, I can eliminate the like terms, or the same factors. So the 3's cancel out, leaving 15 over 2. And now I do the division, 15 divided by 2, which gives us 7 1/2. And we box our answer. The other way of approaching this problem is by adding the whole numbers and then adding the fractions separately. So first we add the two whole numbers, 2 plus 4, which equals 6, and next we add 2/3 plus 5/6. The denominator in 2/3, 3 is a factor of 6, and we just need to multiply both the numerator and the denominator by 2 in order to get an equivalent fraction that has a denominator of 6. So we rewrite the equation, and this time we include the calculation for converting 2/3 into an equivalent fraction with a denominator of 6. So it would be 2 times 2 over 3 times 2 plus 5/6, and then include the parentheses and the 6 that we were adding from the beginning. That way we don't lose anything in our calculations. So now we rewrite the equation again. 6 plus 4/6 plus 5/6. We rewrite the equation on the next line, and this time we can add the numerators. 4 plus 5, which equals 9. And 6 is our denominator. I continue the problem on the top of the page since I've run out of room on the bottom. So I rewrite the problem, 6 plus 9, 6, making sure I get all the symbols and the numbers correct. And now I am ready to simplify the fraction 9/6. So 9 factors out to be 3 times 3, and 6 factors out to be 2 times 3. I cancel like factors, so the 3's cancel, leaving 3/2. 3/2 is the same as 3 divided by 2, which works out to be 1 and 1/2. So now I go back to the equation on top. 6 plus 9/6 is now 6 plus 1 and 1/2, which works out to be 7 and 1/2. And we box our answer. 6 and 1/4 minus 3 and 3/5. Start by converting the mixed number into an improper fraction. So 4 times 6 is 24, plus 1 is 25 over 4, minus 5 times 3 is 15, plus 3 is 18, 18/5. So we have 25/4 minus 18/5. Next, we find a common denominator by multiplying 4 times 5 to get 20. So for 25/4, we multiply both numerator and denominator by 5. So we rewrite that equation with that calculation to be carried out. Now we minus 18/5, and both numerator and denominator need to be multiplied by 4. So the denominator for both fractions will be 20, and we carry out the calculations on the side. So 25 times 5 equals 125, and we write that as the numerator. We copy down the minus sign from above, and now we do the next fraction, which also has a denominator of 20. So 18 times 4 equals 72. Now that both fractions have the same denominator, we just need to do the subtraction for the numerator, or 125 minus 72. I write that equation down carefully, and I do the subtraction on the side to get 53. So the numerator is now 53, and the denominator is 20. 53 over 20 is 53 divided by 20, and I do that calculation on the side, and I get 2 and 13/20. So I rewrite 2 and 13/20 underneath the equation above to show I've completed the problem, and I box my answer. And now I show the other way of solving this problem by using what the book calls the vertical form to add or subtract the mixed numbers. Once again, the problem is 6 and 1/4 minus 3 and 3/5. So I start by focusing on the fraction part of the equation, 1/4 minus 3/5. And I find the common denominator by multiplying both denominators by the other denominator. So 1/4 converts to an equivalent fraction with 20 as its denominator by multiplying both the numerator and denominator by 5, which gives us 5/20. Next, I convert 3/5 to an equivalent fraction with 20 as its denominator by multiplying both numerator and denominator by 4, and I end up with 12/20. So I rewrite the problem as 6 and 5/20 minus 3 and 12/20. 5/20 is less than 12/20, so I borrow 1 or 20/20 from 6, and I end up with 5 and 20/20 plus 5/20. I rewrite that mixed number as 5 and 25/20, so now I can make the subtraction more comfortably. On the next line, I write 5 and 25/20 minus 3 and 12/20. This sets me up for subtracting the whole numbers, 5 minus 3, which equals 2, and the fraction, 25/20 minus 12/20. 25 minus 12 equals 13. And so that's the numerator, 13, and the denominator is 20. So I have the mixed number 2 and 13/20. This is also how we work with algebraic variables. So 1 over x plus 2 over x has a common denominator of x. And so we simply add the numerators together, 1 plus 2, which gives us 3 over x, and we box our answer. Next, we look at 6 over a minus 9 over a. And again, both fractions have a common denominator, and so we just work with the numerators as 6 minus 9 over a. 6 minus 9 equals negative 3 over a. So the answer is negative 3 over a. We box our answer. 4d over 7 minus 3d over 14 do not have the same denominator, so we can see that 7 times 2 equals 14, so we just multiply both numerator and denominator by 2 to get equivalent fraction with 14 in the denominator. So we write 4d times 2 over 7 times 2. Then we copy down the equation from above, minus 3d over 14. And now on the next line, we simplify 4d times 2 as 8d over 7 times 2, which is 14. We copy down the minus sign, 3d over 14. And then on the next line, we can now combine the numerator as 8d minus 3d over 14, which equals 5d over 14. We box our answer. Word problems. John is 5 feet tall. He grew 1 1/3 inches during the last year. How tall in inches was he 1 year ago? Hint, 1 foot equals 12 inches. So here's my picture of John, and I am drawing out his height, which is 5 feet. Now I look at how tall was he 1 year ago? So he would have been slightly shorter by 1 1/3 inch. So I draw his height as a tiny bit shorter this 1 year ago. So this is of course not drawn to scale, but it will give me an idea of how I should solve this problem. You should always draw out your word problems to get an idea on how to go about solving the problem, to figure out what calculations are needed. In this case, the problem is asking how tall in inches was he 1 year ago, so we will need to do a subtraction. 5 feet minus 1 1/3 inches. And 1 foot equals 12 inches. And so 5 feet equals 12 times 5, which equals 60. So 5 feet equals 60 inches. It is important to make sure that we use the same unit of measurements for our equation when we solve our problems. Our equation is 60 minus 1 1/3 to figure out how tall John was 1 year ago in inches. So I borrow 1 or 3/3 from 60 to make 59 3/3. And now I can subtract 1 1/3. 59 minus 1 is 58, and 3/3 minus 1/3 is 2/3, and I end up with 58 2/3 inches. The price per share of stock on A Plus Company was $54 3/4. It rose by 2 5/8. What is its price per share of stock now? So we start by writing down all the given facts of the problem. The price of the stock was 54 3/4. The rise in price was 2 5/8. And what is the new price? So I draw out the problem. First, I draw out what is the price of the stock. Then added an additional distance for the rise in price. And then the two of them together makes up the new price. So it would be an addition problem. 54 3/4 plus 2 5/8 is how we calculate the share of the stock now. So we add the two whole numbers together, 54 plus 2, which equals 56. And then we add the fractions, 3/4 plus 5/8. And I draw brackets around those fractions so that I can remind myself to focus on that part of the problem. I see that 3/4 and 5/8 do not have a common denominator, but 4 times 2 equals 8. So I convert 3/4 into the equivalent fraction where 8 is the denominator by multiplying both the numerator and denominator by 2. And I write plus 5/8 to complete the equation. I complete the calculation in the next line to get 6/8 plus 5/8, which equals 11/8. 11/8 is 11 divided by 8, and I do that calculation on the side. And I figure it out to be 1 3/8. So now I have completed the addition of fractions from the equation above to be 1 3/8, and I add that to 56 to get the equation 56 plus 1 3/8, which equals 57 3/8. So the new stock price is 57 3/8. I write the dollar sign in front because we always need to include the unit, and I box my answer. Here we have a rectangle, and we need to find the perimeter. So the perimeter is found by adding up the lengths of all sides of a figure. So we just need to add up each side of this figure. We set up the equation 3 1/4 plus 3 1/4 plus 2 1/2 plus 2 1/2. I will start by adding up all the whole numbers and then adding up the fractions separately. So 3 plus 3 plus 2 plus 2 equals 10. Next, I add 1/4 plus 1/4 plus 1/2 plus 1/2. 1/4 plus 1/4 have the same denominator, so I just add the numerators, 1 plus 1, which equals 2/4. 1/2 plus 1/2 also have the same denominator, and I add those numerators to get 2/2 or 1. Since the numerator and denominator in 2/4 are even numbers, it can be simplified to 1/2. So the fractions above add up to 1 and 1/2. Now I just need to add 1 and 1/2 to 10 above to find the perimeter. 10 plus 1 and 1/2 equals 11 and 1/2. So the perimeter of the rectangle above is 11 and 1/2 centimeters. Always make sure to include the unit in your calculations and box your answer. The perimeter of this figure is also found by adding the lengths of all the sides. So we write out the equation as 5 3/4 plus 5 3/4 plus 3 1/3 plus 3 1/3. And this time I will solve the problem by converting the mixed numbers to improper fractions. So the denominator 4 times 5, the whole number, is 20, plus 3, the numerator, is 23/4. So both 5 3/4 become 23/4. Next, we convert the mixed number 3 1/3 to the improper fraction 10/3. Now we convert both fractions to equivalent fractions with a common denominator of 12. So we multiply both the numerator and denominator of 23/4 by 3. So the denominator equals 12. And then I do the side calculation of 23 times 3, which equals 69. So the equivalent fraction is 69/12. Now I convert 10/3 to the equivalent fraction with 12 as the denominator by multiplying both numerator and denominator by 4, which gives us 40/12. And now I am ready to do the addition. And I write out the equation as 69/12 plus 69/12 plus 40/12 plus 40/12. I do the calculation of adding the numerators on the side. 69 plus 69 plus 40 plus 40 equals 218. The sum of those fractions is 218/12. Now I need to simplify that fraction in its simplest form. I prime factorize 218 to get 2 times 109, and I will stop there because 109 is not divisible by 3 because its digits 109 add up to be 10, which is not a multiple of 3. So I know that there will not be any more common factors between 218 and 12 other than the prime factor of 2. Next, I line up the factors corresponding to the numerator and denominator, and I cancel like factors. So I will cancel 2 from the numerator and denominator, which leaves us the improper fraction 109/6. 109/6 is 109 divided by 6, and I do the calculation there to get 18 1/6. So the perimeter of the figure above is 18 1/6 inches. And we box our answer. Evaluate 1/7 minus open parentheses, 1/7 minus 1/15 close parentheses. I can remove the parentheses by changing all the signs of the numbers within the parentheses. 1/7 right now is a positive number. I need to change that to negative, and the minus sign needs to be changed to positive. So I rewrite the problem as 1/7 minus 1/7 plus 1/15. and 1/7 minus 1/7 equals 0, so it cancels itself, leaving 1/15 as the answer. And I box my answer. 2/3 minus 15 and 1/4 minus 4 and 1/2 plus 3 and 5/6. First, I write down the equation, making sure I get all the numbers and figures correct. I will first gather the fractions together along with their signs and do those calculations up front. So I have 2/3 minus 1/4 minus 1/2 plus 5/6. I give myself plenty of space between the characters and symbols so I can see what I am doing. Next, I gather the whole numbers along with their signs and do those calculations on the side next to the fractions. Minus 15 minus 4 plus 3. The fractions all have different denominators, so I need to find the lowest common denominator and use equivalent fractions that have that denominator. The denominators are 2, 3, 4, and 6, and I need to find the prime factors for all of those numbers. Quick review from the textbook, page 49, the least common multiple or lowest common denominator. To find the lowest common multiple of two or more given numbers, we write the prime factorizations of the given numbers and find the highest power of each factor that occurs in any of the factorizations. The product of these highest powers is the least common multiple, or the lowest common denominator. You may also watch my video, lesson 23, on greatest common factor, least common multiple. Okay, back to the problem. The lowest common multiple or least common denominator is 2 times 2 times 3, which equals 12. Next, I need to convert all those fractions into their equivalent forms that have 12 as the denominator. For 2/3, I need to multiply numerator and denominator by 4 to get 8/12. For 1/4, I need to multiply numerator and denominator by 3 to get 3/12. For 1/2, I need to multiply numerator and denominator by 6 to get 6/12. And for 5/6, I need to multiply numerator and denominator by 2 to get 10/12. Now that I have all the fractions with a common denominator, I can add and or subtract the numerators accordingly. Meanwhile, the whole numbers minus 15 minus 4 plus 3 simplify to minus 16. So now I gather 8 minus 3 minus 6 plus 10 of the numerators. And then I also write down minus 16 to complete the equation. 8 minus 3 is 5, minus 6 is -1, plus 10 is 9. So I have 9/12 for my fraction minus 16. I factorize 9/12 to be 3 times 3 for 9 and 3 times 4 for 12. I cancel like factors, 3, to end up with the fraction 3/4. So now I have 3/4 minus 16. And I subtract a larger number from a smaller number. I like to turn it into an addition problem, changing the sign of the larger number. When adding two numbers with different signs, you treat it as a subtraction problem with the greater number giving its sign. In this case, 16 is the larger number and it is negative, so the answer will be negative. 16 minus 3/4 is the same as 15 and 4/4 minus 3/4, which ends with 15 and 1/4. So since the larger number is a negative sign, the answer will be negative 15 and 1/4. And we box our answer. When you are solving complex problems like this, you will find there are many ways of getting to the right answer. And now I will show you a different way to approach this problem, which is solving each calculation one at a time from left to right. So first we look at 2/3 minus 15 and 1/4. First, I convert to equivalent fractions with the same denominator, which will be 12. Multiplying both numerator and denominator by 4, which gives us 8/12. Next, 15 and 1/4. 1/4 becomes an equivalent fraction with 12 in the denominator by multiplying both numerator and denominator by 3, which gives us 15 and 3/12. Now I subtract 8/12 minus 15 and 3/12. And I can change the signs by writing a negative sign in front of the parentheses and changing the signs of the fractions within the parentheses. So minus 15 3/12 becomes a positive 15 3/12, and the positive 8/12 becomes minus 8/12. So now I do the subtraction. The numerator from 15 and 3/12, 3 is smaller than the numerator of 8/12. So I will borrow 1 from 15, or 12/12 from 15, to make it 14 and 12/12, plus the 3/12 that was already there to make that fraction 14 and 15/12. Now I can subtract 8/12 comfortably, and I end up with 14 and 7/12, or negative 14 and 7/12 from the sign in front of the parentheses. Okay, so then the first part of the equation, 2/3 minus 15 and 1/4, has simplified to negative 14 and 7/12. Now I am ready to do the next part of the equation, which is minus 4 and 1/2. And I convert 4 and 1/2 to an equivalent fraction where 12 is the denominator. And I multiply both numerator and denominator by 6 to get 4 and 6/12. So now I have minus 14 and 7/12 minus 4 and 6/12, which equals negative 18 and 13/12. I can now take negative 18 and 13/12 and do the last chunk of the problem, which is to add 3 and 5/6. 3 and 5/6 needs to be converted into an equivalent fraction with a denominator of 12. And I do so by multiplying both numerator and denominator by 2. So now I have negative 18 and 13/12 plus 3 and 10/12. When you add numbers in which the signs are different, you treat it as a subtraction problem, and the bigger number gives its sign. In this case, negative 18 and 13/12 is the larger number, so the answer will be negative. So 18 and 13/12 minus 3 and 10/12 equals 15 and 3/12, and the sign is negative. To find the simplest form of 3/12, I factor out the common factors. So 3 factors out to be 3, and 12 factors out to be 3 times 4. The 3's cancel, leaving 1/4. So the answer is negative 15 and 1/4. I rewrite the answer on top, negative 15 and 1/4, and I box my answer. The exercises for this lesson, adding and subtracting fractions, are on pages 67 and 68 of the textbook. Please do as many problems as you need to get a firm grasp of this material, and especially take on some of the word problems, checking your answers with those in the back of the book. If you find my video helpful, please like, subscribe, and share. And thank you for joining me at Do the Math America.